I hope you can all hear me. So welcome everyone and thanks for joining us today. I'm Francesca Pedicini, business developer at ACCA Software. I'd also like to introduce my colleagues and industry experts, Eva Madonia, who works in the technical support team, and Tony De Palma, who's involved in product localization attack, and also coordinates various projects in connection with our technological partners. Tony will be our main presenter today. Before we begin, I wanted to thank BIM CREW and the India BIM Association for organizing this event, and particularly thank Amsaja and Amarnath for their great support. Just a reminder, please do ask questions as we go in the chat box that you'll find in your control panel. We will do our best to reply during this session. Rest assured that the presentation today and on-demand recording will also be available. So without further ado, I'm going to pass over to Tony, who's going to introduce you to who we are, what we do, and take you over the presentation of ACCA Software's journey in developing BIM and OpenBIM solutions.
Okay, then thank you, Francesca. Let's move on to our presentation. Today's overview of ACCA's cloud technology and Open BIM solutions starts off with a brief introduction to ACCA Software, who we are, and where we are going for the future. So meet the team. I am Tony De Palma. As Francesca was saying, mainly involved in AEC product localization. Francesca with international business development, and you have at your disposal Ivan Madonia, who's our BIM consultant and technical support member. He'll be able to provide further answers to your questions or any doubts that you may have. Where did it all begin? This is our ACCA Software site, the Dragonfly site. ACCA was established back in 1989 and is our modern company headquarters that was completed in 2016 and located just 60 kilometers from Naples, right in the middle of the countryside. It's a futuristic hyper-technological building, fully energy independent with over 220 kilowatts of solar power installed and 30 kilowatts of wind power generators. Just as many well-known success stories, ACCA started off in a basement where our CEO here that you can see in the picture on the left, Guido Cianciulli, started programming the first AEC software solutions over 32 years ago. Of course, we're in one of the most hyper-futuristic buildings in harmony with the environment and the territory. In these past 32 years, ACCA Software has been developing software solutions with an important role in the AEC industry, actively contributing to the digital revolution and the construction sector technological advancements. We have over 90 software solutions here. On the right hand side, you can see just a few numbers regarding our company. Over 210 employees. Average age of each employee is 35 years old. We also have the first certified CDE solution in the world by Building Smart. Let me just move on to showing you a brief introduction of our BIM authoring solutions. Edfish is one of the main solutions for architectural BIM design, also including various tools for architectural rendering and ArcViz presentations. It also has various tools for VR viewing and technology. I think we have a brief video just to show you the capabilities of its output. So as I was saying, Edfish has been continuously evolving ever since its launch back in 2012 and has become a major turning point for ACCA and also for our clients. Of course, it competes with other well-known solutions such as Revit and ArchiCAD and includes an unparalleled range of tools including AI rendering, real-time rendering, and also brings to you the possibility to use an extensive library of design resources completely online and for free. It also includes a landscape modeling environment together with an MEP modeling tool with smart map tools and intelligent connections. And it's basically the first solution which allows you to do map modeling in 3D. Moving on to further BIM authoring solutions, where we also deal with structural design. Let's have a quick overview of Edilus, which also covers the design and management aspects of the industry for structural calculations. Structural design, as I was saying, for concrete, steel, masonry structures, including all of the modeling tools necessary to build up your structure, verify stresses, and other kinds of mechanical actions on the building. It's capable of producing all of the construction documentation, reinforcements, provides also a complete overview in reports and verification results in automatically generated documentation. We also have the possibility to do comparisons between existing buildings and design structures. Just a couple of the views of the possibilities of creating documentation and verification output. Next up is our renewable energy solution. We have many other tools for renewable energy design. This is our Solarius solution, which also has a 3D BIM modeling environment, just to keep focused on having the possibility to model in 3D and then also address all of the system configuration aspects for choosing your modules, coupling the models to inverters, and of course producing all of the documentation. It also produces financial analysis documentation with regard to energy consumption, the profitability metrics, payback time, net present value, and internal rate of return. These are all produced automatically and based on the design of our system. Another important feature within our scenario of BIM authoring solutions is also scaffolding design. Again, a solution which brings BIM modeling to the entire workflow based on either buildings that can be designed with our architectural design software Edfish, but also supporting the possibility to import IFC files coming from other BIM authoring solutions, such as Revit, such as Allplan or ArchiCAD, for example, and upon which we can place our scaffolding design in 3D detailing with cost evaluations and simulations for health and safety also aspects. Again, Certus also provides automatic drawing output and reporting with also technical checks. Next up is our construction estimating suite of solutions, Primus. Primus allows us to deal with all of the aspects of BOQ, quantity takeoff from both CAD and IFC models, and also allows us to deal with construction cost estimating aspects too. Primus was the first software produced by ACCA Software back in 1989, as I was saying, and has become a national standard here in Italy for its ease of use and the possibility to also access all of the national and regional price books and price lists. Another important solution for our BIM authoring software is the Thermos suite of solutions available on the international market with our Thermos Bridge and also Thermos Plus. These two solutions deal with the possibility to simulate dynamic calculations of our energy performance aspects regarding our building based on the, of course, based on the materials used for our building, and the possibility to also assess the energy performance in relation to thermal bridges. Let's now move on to seeing the cloud integrated solutions and our range of cloud CDE tools and the APIM plugins. These, of course, enable our users to build up their own workflow to meet their increasingly demanding workflows and BIM processes. Of course, for viewing, managing documentation, for federating BIM models, accessing the document management system with real-time collaboration tools and BIM coordination functionalities. ACCA software has the largest ecosystem of plugins and services which are developed with reference to the main standards related to information management of building works by applying the BIM methodology, now becoming a worldwide workflow to also facilitate the exchange of information between all actors involved in a project and ensuring the creation of a coherent BIM model, or if you prefer, digital twin. It enables us to cover all of the possible fields of application, from design to construction, from building, from operation of the building, and of course through to demolition, and therefore through the entire life cycle of the building. Of course, in this scenario, we can't avoid referring to the concepts related to OpenBIM and, of course, the exchangeability of data between all operators involved in a BIM process and not necessarily linked to a specific software solution. We believe at ACCA that this represents the winning strategy for the construction industry of the future and, of course, of the future of BIM. From a high-performance model and data viewer, we also have document management, scheduling, coordinated cloud-based document editing, model assessments in real-time virtual reality experiences, also linking up to GIS, clash detection workflows, and of course IoT, the Internet of Things. These are just a small selection of the possibilities that ACCA software is capable of offering today. ACCA BIM solutions are developed with reference to the main standards, as I was saying, related to information and the way we deal with the management of documents and data of any building project by simply applying the BIM methodology in all its variations, and also facilitate the exchange of this information between all of the actors, as I was saying, that do not necessarily need to be linked up to specific software tools. In this scenario, we have to understand the need to identify OpenBIM as a working method based on ensured interoperability and collaboration process between all of the specialistic disciplines involved in the design, construction, and the commissioning of buildings. It basically means that we need to use an open and neutral data format, seeing as IFC is not maintained by any specific software company, but it's an initiative that derives from the Building Smart Association. In fact, the OpenBIM project is a universal approach to collaboration during the various life cycles of the building, and also guides the digital transformation of the construction sector. Of course, its commitment is to improve and continue to develop the open and international standards for infrastructures alongside the current use for buildings, and of course guarantee the dissemination of their use. If we transpose this into the context of building information modeling, interoperability consists in the possibility to exchange data contained in the initial design model. For instance, using the BIM authoring solutions that we just had a quick overview of, for instance, starting from the architectural, leading through to the structural design, thermal performance analysis, and so on. If we understand these main aspects, these main principles, we can understand that transfer of information becomes a communication aspect between all of the various actors involved, and is at the heart of the entire ecosystem of tools that we are proposing today. The IFC format is an open format which was created with the aim, of course, of making this collaboration between the various professionals as seamless as possible. It means that the open format is non-proprietary, and of course it has an open technology to anybody involved in the AEC sector to adopt and to use. And it means that we can provide models that can be viewed, analyzed, and reused by all of the various software solutions that support this format. So let's see what ASBIM actually is. It's a cloud-based service that allows you to upload, view, and manage projects, and also share them with other colleagues with the full possibility to access data, documents, and models from anywhere. You can structure the project with 2D, 3D assets, information, data, and external documentation. It's a BIM collaboration software with specific team communication services for taking part in project meetings. It also includes an internal meeting application where you can view all of this data concerning 2D, CAD files, 3D models, therefore BIM models, in real time while continuing to work with your colleagues on projects, structural calculations, reports, BOQ information, construction project management related information, and so on. You can even activate other useful tools and services by visiting the ASBIM store, a sort of app store where you can simply choose the required app that you need for your workflow, purchase it directly online, and therefore customize your entire ecosystem of your ASBIM experience. Moving on. So as I was saying, we have an integrated ecosystem of cloud applications to manage the digitization of buildings and infrastructures in an easy, secure, and collaborative manner, exclusively online using any device, such as a tablet, a PC, or a smartphone. So what are the main aspects of Cloud BIM and the integrated system of tools? With full data availability and data exchange in mind, the entire ecosystem is focused on these three main aspects of BIM-oriented workflows: design, the possibility to share, and the possibility to also verify. As you already know, the OpenBIM ecosystem identifies a working methodology based on the possibility to interoperate, to exchange data, and collaborate between all of these specialistic disciplines involved during the design and construction phases, leading through to demolition. It basically means that the entire system allows us to access the OpenBIM workflow using API technology or API software technology. There's even the possibility to access these other open formats such as PDFs, RTF files, normal text files, and so on, and in some cases also access and read the proprietary format files such as Revit files. That's also included within our Cloud BIM integrated system. So, not being controlled or governed by any specific software manufacturer, the IFC format can be used to exchange and share data between the various applications. As I was saying previously, between architectural design, structural, MEP, or even health and safety. This sort of reconnects us to what we were saying previously when talking about BIM authoring tools. Passing on to the second aspect, which is the possibility to share information. This, of course, simplifies the need to be continuously coordinating the design and construction team throughout the entire process, because we have the possibility to access high-performance tools for managing these, let's say, shared and coordinated exchanges of data, or even editing that data within documents and models. Team members can therefore access the CDE, operate with the other members of the design team or project management team, for instance, deal with facility management tools, and of course with the viewing tools, which we'll see afterwards, to view all of the BIM-related information regarding the entire project. In the verification phase, the third aspect, let's say that we mainly focus on the model and data validation tools. Clash detection, just to mention a few, model checking, even IFC editing, which is something that I would like to show you afterwards, and where we are leaders, world leaders in the possibility to edit IFC geometries and datasets. So with all of this in mind, we can truly say that ACCA has the largest number of IFC certified software from Building Smart. I think we've reached over 30 software solutions or BIM software solutions which are fully certified for import and export by Building Smart. We have also developed the first IFC editor capable of working both as a desktop application and also as a cloud-based solution. So who's it for? I think we've already answered this as we were going through. It's for anybody involved in the AEC industry, therefore architects, engineers, surveyors, BIM managers, and BIM specialists. With regard to file management, we'll start to have a look at some videos now that show us how all of this workflow is entirely guaranteed throughout the entire ecosystem of the BIM ecosystem of tools, including document management, the possibility to profile our users and therefore grant access for viewing, editing, uploading, and so on, data to the system, the possibility to also add metadata management with our hashtag BIM system, and define a structure. Let's have a look now at a video where we'll be able to see access to the BIM platform. Here we have all of our ecosystem where we can profile new users, setting up the type of role that they'll be playing within the project, whether they are active or not active within the project. We can set up companies and groups. Okay, these are profiled within the entire system. And we can also access a very important feature for event logging. So we know exactly who has been doing certain tasks within the workflow. And therefore, everything can be tracked down with full compliance with one of the OpenBIM and the Building Smart requirements, which is the traceability of events. So here we can profile all of our users. We can add, for instance, this is our structural engineer. They can be activated, deactivated by the BIM management, which has, let's say, a higher level of administration rights. And here we can see that we are structuring our project with various folders and subfolders containing all of our PDFs, documentation, our DWGs, our CAD file information. Here we have some Revit files, SketchUp files, IFC models. We have also an Edfish model. And of course, we have the possibility to access all of the event logging details which are going behind each of these files. And we can even go back to previous versions of a file that have been changed in time to see what's been going on and who has been the author of such modifications. The hashtag BIM workflow enables us to add metadata to our files. That also makes searching for specific information easier. Imagine having thousands and thousands of documents and files within our system. Adding this metadata allows us to access specific parts of information which are within documents or within the contents of those documents. This is an example of how we can add this hashtag BIM information. Here we're going to add information with regard to document management, referring to a type of discipline. So this is an architectural document relating to the architectural design. We'll also add another hashtag metadata for regarding another category. In this case, this is a graphical model of the project. And therefore we can populate, we can add as much information as we feel necessary to each of these documents within the folder, and use the hashtag BIM filters to simply find specific documents. Just imagine how many documents we have, 151 documents in one folder, and we are now selecting the metadata hashtags as we define them to just filter down to the specific documents that we're looking for. This is one of the structural documents referring to structural design discipline, and we can also view specific information regarding the geological analysis before starting to build the foundation structure. And we also have specific data regarding terrain analysis. So we're just filtering down to those specific documents that we were looking for, and even search for specific values which may have been included within those documents. Therefore, by selecting a specific value, we can access the document that contains that selection of text. As I was saying, we also have the APIM Browser, which is a high-performance model viewer for viewing both models and, of course, data. We can easily create hyperlinks between documents with simple drag and drops. Here we can see briefly how the model can be viewed online using the browser, which of course brings us great freedom to be able to use these tools from wherever we are, and of course from any device. It has an extraordinary power behind its the viewing technology. In fact, we can view very, very complex and very large models with the great comfort of simply having a browser, therefore not requiring any specific software. It's a 3D BIM viewer for large file viewing, and this, of course, as I was saying, is part of the APIM system, allowing you to view and manage all of the data, documents, and models directly online. We also have the possibility to federate multiple IFC models and a selection of other 3D BIM model formats into a single BIM model environment. We can also collaborate with connected users. Therefore, we can collaborate in real time with other users that are connected on the same model, and have a centralized, therefore, access to a document or a 3D model where we can discuss, we can unite and discuss about problems or potential problems that can be visually verified on the model itself, and possibly solve those potential problems while connected on the APIM browser workflow. Let's have a look at the capabilities of APIM browser. Again, we're on the CDE, where we have opened up an IFC model. We can even view the a simulation of our sunlight during the day. We can take measurements directly from the model, have all of that information available on the right-hand side in the properties box. We can cut through the model with a section plane, federate various models. Therefore, with a simple drag and drop from our document management system, we can federate multiple models. For instance, the architectural, the structural, the MEP models can be federated together and viewed in real time using APIM Browser. We have, of course, access to all of the information regarding each model and, of course, each of the building components in the model. Simple drag and drop allows us to link up and associate information from the document management system to specific objects on the model. Here we're looking at some energy performance aspects regarding the structure. And here instead, you'll see we are looking at some of the structural design aspects. In this case, the reinforcement bars in columns, aspects regarding our floor slabs, And this beam here, we can see the reinforcement bars with the stirrup layout and reinforcement bars going across this section of a beam. So we have a unitary approach between 3D aspects and the related documentation, and of course the data. Again, using the hashtag BIM, we can set up extra metadata, a transmittance value which comes from let's say one of our BIM authoring solutions, and use that data to filter all of those windows in this case, or openings, where we have specific transmittance values. So we can have a look at that data both from let's say an analysis point of view and also a visual or graphical point of view. Just to, we'll have a look also afterwards at this railway station, the Naples railway station, where we have over 50 IFC models which have been federated together, just to give you an idea of how powerful the viewer is and access to all of the information regarding a railway station, both in terms of its complex geometries, the building components. Here we're viewing all of the information regarding these front facade support structure elements, and so on. We were able to see there the federation aspects between various and multiple viewers. In fact, APIM Viewer allows the user to browse and manage every single aspect of the model as if it was produced by a native BIM authoring software. So I need to underline the fact that we are using the open file format IFC and managing the entire workflow between the various disciplines that have been addressed by the various actors involved in a specific project, even if they're using different software solutions. As long as let's say this output, this design output, converges towards IFC, ACCA software is providing the most advanced and cutting-edge technology solutions to enable and to govern the possibility to coordinate the digital BIM model, integrated further information within a single pipeline, which is the APIM ecosystem. The result of a multiple federation of models allows us to address each and every one of these in a centralized core solution. Let's have a look at APIM Browser with the federation tools. Here we have a very extensive territorial scale map where we have very diverse infrastructural projects, all located on this map, extending over 7 kilometers of territorial, let's say, information. We have a wide variety of models. Let's have a look at this motorway bridge here, coming from a point cloud laser scanning survey, a railway station with another point cloud survey which was taken nearby. All of the details regarding this railway track. So you can see how many details there are in there as we zoom in onto each individual model here. We have also another representation, another point cloud scan survey with all of the information regarding 360-degree panorama photographs which were taken during the campaign. We can even add links to videos. This case is this model here is a Revit file, which was also converted from the native file format to, let's say, an intermediate converted geometry, which enables also to view Revit files Here we have another train station, a very old train station, and here we have the complete BIM model of the ACCA software headquarters. So as you can see here, we are converging towards a unitary and centralized data and model management workflow where we can access all of the information coming from different design disciplines. And that ensures the international Building Smart requirement of guaranteeing interoperability and the possibility to exchange data between everybody. So we do not believe in the aspect of keeping native file formats between operators of the AC industry. We want the entire workflow to be open and therefore guarantee complete freedom of collaboration between everybody. Here we have our structural design, architectural design coming from a point cloud survey used to build up the models. Here on the top of this mountain here we have a very old church which was also scanned inside, and for which we also scanned all of the monumental and let's say heritage BIM. Another important aspect of BIM is also heritage BIM aspect. Of course, we're talking about existing buildings where we also need to maintain information and data coming from the past. So inside here we also have specific links where we can view historical information, photographs referring to these heritage, let's say, aspects of this church. We even managed to produce some very high quality renderings of the inside of this beautiful church here in 360. And for which we can run a complete comparison with the state of the art, or if you wish, the current situation that was surveyed during the campaign. Moving on to BIM Editor. This is, earlier on I mentioned that we are the only company, the only software company involved in the OpenBIM workflow to even produce an authoring, a BIM authoring for the IFC format. It's called BIM Editor, available as a desktop solution and also as a cloud-based solution. It's an exclusive IFC BIM authoring tool for therefore modifying the geometry, deleting parts of the geometry, or even replacing parts of the geometry with other, let's say, 3D information. There's also a data management tool within where we can see all of the IFC structure and edit that data. It even allows us to import custom property sets using the IFC files, which of course have to be created in compliance with the IFC schema. It has various features. For instance, we can view the entire model, we can view certain parts of the model using the visibility tools. It enables us to access other tools for creating selection filters and so on. And of course, where we can, for instance, access all of the information that was probably added while we were on the cloud using the hashtag editing tools and property template editors using our APIM Browser. It enables us to also integrate with other commonly used solid modelers, such as, for instance, SketchUp, Blender, or Rhino Grasshopper, for adding additional geometries. and the possibilities also produce renders, produce document output such as reports and technical tables, add even materials. This is something quite big because IFC does not contemplate the possibilities to add materials to their geometries. We only have, let's say, very simplified color sets and information which describe the materials, but we cannot assign visually, let's say, accessible materials. Whereas with BIM Editor, we have the possibility to add materials to each of the objects directly within the 3D view. I think we have a video where we can also take a glimpse of that. Alongside also the possibility to access a very large library of BIM objects and objects which are available online, as I was saying. These are all for free, so we can choose furniture, add materials, grab other kinds of building asset information directly from the cloud using our online BIM Object Library, and therefore enrich the entire IFC model again with extra assets and resources. We can produce all of our documentation. So if we're using IFC models, we can still produce all of our floor plans, elevation views, cutaway drawings, and so on. And again, we can then export all of that information with all of the additional resources, information that we just added using materials, extra furniture, and so on, or even extra geometry assets, and export them to other formats, create PDFs, or simply export them to DWG and DXF file formats. As I was saying, it also includes real-time rendering, the possibility to also produce videos, share the entire IFC model again with the BIM CDE ecosystem, and even navigate through the model in immersive virtual reality using a compatible head-mounted device. Again, let's have a look at this brief video where we'll see some of the functions related to the use of IFC models with our editor. A very simple building here with not many, let's say, details included. We have our geometries, which of course are being viewed also in 2D. We can access the properties box here on the right to add all of our extra information. For instance, we received this from an architect which is was working on, let's say, a draft copy. And the very important aspect here is that we can edit the IFC model. So we're still in an OpenBIM workflow here, but we're editing the IFC model. So even if this was generated from some other BIM authoring, such as ArchiCAD or Revit, for instance, we can access those aspects regarding, for instance, walls, these chimneys on the top of the roof. This is just an example here, just to show you how we can modify the geometry while remaining in the IFC domain. As I was saying, we can add extra detailing, such as, for instance, vegetation, grabbing these directly from our online BIM Object Library. We can choose among hundreds and hundreds of different vegetation essences. And here we're seeing the integration with SketchUp, where we can, for instance, modify parts of additional geometries using the typical tools available in SketchUp. I think many of you may have used SketchUp in the past. If not, we also have the possibility to do the same thing, adding geometry. This is just an example here, adding some text. And we can also do this with Blender or with Rhino Grasshopper. So these additional geometries can be addressed with these other solid modelers and brought back into the IFC model. We can run a sunlight simulation just to have a look at how the shadows will be developing, and more importantly, add materials, which is something really big for IFC, because there's no other editor out there that allows you to add materials, PBR materials, allow me to say, on top of the IFC geometry. And here we can even produce our renders using artificial intelligence denoising after having applied materials, vegetation, and as many assets as we feel necessary to, let's say, make sure that the visual output and our graphical representations are satisfactory for our client. Very quickly, let's have a look at how we can produce the documentation. Floor plans, cross sections are automatically produced from IFC Editor. Here we'll take a look at the output that we can produce, for which we can also select the different representation style. We have we have various types of styles where we can choose from, or we can build up our own. And of course, add measurements manually if you require, using the snap nodes, or even use automatic measuring tools, by which at a click of a button we can apply all of the measurements to all of the rooms. Same applies to our front facade views. Here the elevation view, where we can add some shading effects just to give a more precise idea. And with simple drag and drop from the project navigator here on the tree structure on the left, we can bring them into our working drawing or let's say our final documentation to build up all of our project documentation. If we make any modifications to the model, as we saw, all of the relating documentation is updated. So you can understand the great power behind that functionality, where we do not need to go back to each and every document to go and make the modifications. We have a complete and seamless updating of all connected documentation. Here we're having a look at the rendering output, and the possibility to also produce video in real time using our BIM Video Studio, which is also included, making us BIM Editor a true BIM authoring for IFC files. Exceptional tools at your fingertips for any kind of workflow and for any kind of design requirement. We'll have a look at some of the other real-time rendering tools and functionalities afterwards. Just a quick view there. Okay, BIM Point Cloud, another important feature that which we have only just recently also included in our last update of Edfish, the BIM authoring. BIM Point Cloud, as I was saying, is also available as an extra plugin for the BIM Cloud integrated system. So you can choose to have BIM Point Cloud in your cloud integrated toolbox of applications to deal with fast and powerful integrated point cloud, let's say, workflows. Of course, you have a revolutionary system that integrates all of the digital scanning technologies coming from a typical point cloud scanning campaign. We have various technologies that we support, various file formats, of course, that we support, and of course, very useful to create the BIM model from a point cloud, and therefore, in this case, we are covering the scan to BIM workflow. I think we have a video now where we can see it in action. I'll just reduce the volume a second. We have 5 main steps in dealing with point cloud to BIM. Let's have a look now at how it works. Within Edfish, we access the cloud integrated system as BIM. Simply log in after choosing our language. So we log into our account.
Choose the Upload File option, or simply drag your point cloud file into your cloud workspace. View your point cloud file in 3D. With the selection box, identify which part of the point cloud you want to import into Edfish. This allows you to work only on the portion of the point cloud that you need to generate your BIM model. Click on Download to import the point cloud selection into Edfish. If necessary, import multiple different parts of your point cloud. Use the object grip to align the point cloud along the X or Y axes. Add a vertical section plane. Change the section plane color. Disable the point cloud and section plane viewing options. Activate the HRS Manager to quickly define the levels. Move and align the point cloud object grip to the 0 level reference. Now align the point cloud 0 level reference to the corresponding HRS 0 level reference. From the foundation level, now add the underlying sublevels below the 0 level reference. Align the level elevation height, taking advantage of the point cloud snap modes. Repeat the same procedure for further sublevels if present. From the roof level, add any extra levels that may be present above. Align the level elevation height, taking advantage of the point cloud snap modes. Repeat the same procedure for further upper levels if present. Add a horizontal section and position it at the desired level. Now open the level where you previously inserted the section and start modeling your architectural objects, such as, for example, the building envelope. Take advantage of your point cloud accelerators. Select the object start and end point. Change the alignment axis. Edit the length across both directions. Visually identify the thickness. If necessary, fix the alignment angle. View the detected thickness, rounded and already used on the project values. Choose the correct thickness value and confirm data input. Repeat the same operation for all other objects. In case of variable thicknesses, choose the variable thickness option. Visually identify both thicknesses and confirm values. Insert openings taking advantage of the point cloud accelerator tools. Let's see an example for a door. Specify the door start and end point. You have a dedicated viewing window. With part of your point cloud and the overlaid architectural model, you can visually identify the opening dimensions. View measured, rounded and last used values. Confirm the desired values. Choose the opening direction. Finally, confirm your data input. And now let's see an example for a window. Specify the window start and end point. Again, in the dedicated viewing window, with part of your point cloud and the overlaid architectural model. Visually identify the opening dimensions. View measured, rounded and last used values. Confirm the desired values. View the 3D model. Deactivate the point cloud and its sections. Use the functions in Edfish to work faster. For example, associate characteristics from one fixture to another. Or perfectly align the openings. Vertically. Or horizontally. You can easily complete your architectural model and view it with textures and shading. Also produce project drawings, such as a floor plan or any document you need for your project.
Okay, so that was the latest update of Edfish with the support of Point Cloud. I think we have another video here showing the same technology, but this time using BIM Browser, therefore BIM Browser with the Point Cloud plugin. Here we have an archaeological site for which we ran a laser scanning campaign just near Naples. Here we managed to produce a federated combination of models between an Edfish architectural model here, overlaid on top of the archaeological point cloud survey. Again, just to show you the great power behind the technology using this viewer, we have a complete view of our point cloud information within BIM Browser. BIM Reality, another important aspect with regard to enhancing the BIM methodology and viewing capabilities with VR technology. In fact, ACCA software, I think you've managed to gather the main message here is that we have continuously been pushing the boundaries of traditional AEC design workflows, implementing the best possible viewing experiences deriving from the past 30 years of know-how in this particular field. In fact, we've taken the visualization experience even further with our virtual reality tools, which in this case are based on our Unreal Engine partnership with Epic Games. ACCA Software is also partner with Epic Games. In fact, we are part of their enterprise partnership program. Therefore, we are providing the best possible AEC viewing capabilities with the also with the ability to interact while viewing the BIM model. This works out to be also a digital prototyping process, which is something that we're not very used to even thinking of, are we, with when talking about buildings, because when we build a structure, when we build a construction project, it's already the final version. There's no prototype. Whereas, for instance, in the automotive industry, they build prototypes, they do a lot of check and verifications before moving on to the manufacturing process. Now we can finally build up our prototypes, but in a digital world, and therefore adopt visual code checking, for instance. We can have a look at our MEP systems while taking a tour of a digital version of our building. Another solution is our APIM GIS. This tool allows us to easily create, edit, and share GIS files directly in the cloud without any kind of third-party software. So everything that you need is available within our integrated system. All you need to do is simply create your own document with a folder structure and select the APIM GIS map option. This provides us with a series of features, including document export to the OpenGeoJSON file format. Let's have a look at a video. In fact, here we can contextualize our models on a territorial scale map. Here we can see our GIS service at work, where we have this railway section. And we have, I think, over 32 kilometers of railway track here, all described with information regarding the signaling structures and other connections to different parts of the railway transportation system. Documentation can also be accessed. Again, we're going to jump to the Napoli Centrale railway station, where we can also have a direct link to the IFC model and view it directly within the browser. So we have a complete view of the project with all references to urban and environmental references. Here we can see these technical documentations regarding the internal lifts within the railway station itself. APIM BCF, also another specific tool for BCF, or BIM Collaboration File Format Management. A very important tool within the coordination process, because it allows us to import and export issues, markups, and share them across the platform. Here we'll have a look at this video, where we can see the MEP model also shared across the platform in the IFC file format, and where we can have a look at this interference here between the structure and the MEP ducting system. If we move into the issue and markup view, we can add, in this case, an issue, set its state, give it a title, describe what kind of problem we're looking at. In this case, it's an interference between the ventilation system and the structure, and assign it to one of our collaborators. When we save, our collaborator is then notified to take action on that specific part of the model. In fact, he's already resolved the problem, shared a modification, and that enables us to have a look at it. Now we're both connected online through the notification system and communication, the online ASBIM chat tool, where we can both access the same view. So we have one of the members of our team in one location in an office, and the other in some office somewhere else in the world. And we're both having a look at the issue that we were talking about and how to solve it. So literally collaborating and coordinating issue resolution in real time using the integrated chat system. We're both looking at the same aspects together within the browser. Here we'll have a look at a much better look at the railway station, the Naples railway station, and the convergence of these digital, let's say, advancements in viewing data and therefore viewing the digital twin of the entire railway station. We're talking about over 50 IFC models here. Great fluidity, fantastic performance in terms of accessing all of these models with all of the references to the territory and where the train station is actually located. Here we're going to concentrate on the IFC models. Each of these on the left-hand side is an individual IFC model, which is they've all been federated between each other. We can act on the visibility settings to concentrate our attention on specific aspects regarding, for instance, these elevators. And therefore, for each of these, also access the complete set of documentation, the PDFs, technical drawings, manufacturer information, user manuals even. They can all be stored on the system and linked up to the individual components visible in the model. We can even filter using the hashtag BIM workflow again to find specific documents or to look for specific information regarding each and every component present in the building, in the infrastructure, in this case in our railway. Very, very important aspect with regard to maintenance and facility management. Here we're still navigating within the browser and moving along across the various spaces, and for which, of course, we can interact on each of the components to access the relating documentation that you can see here appearing up at the right-hand side. And there you go. Of course, to push things even further, as I was saying, how about using the IFC model for an immersive virtual reality experience where we can dive in and have a look at all of these geometries federated between each other in a single environment, and also access information. Very useful also for the verification phase, where we want to assess the experience that our passengers are going to have when traveling to and from this railway station. So we can jump around, selecting one section or another. And here's another example of another 32 kilometers of railway tracks, for which we have also added other information regarding these track connections, the signaling systems here, accessing all of the information regarding maintenance, very important on today's very busy railway tracks, and to keep full interoperability on both the modifications that are being brought along during the maintenance aspects, and of course of updating all of the relating documentation. This can also be entirely viewed within VR or even with real-time rendering. Real-time rendering, again, based on the Unreal Engine 4 rendering engine. Another tool, another important tool is APIM Blockchain. So what's APIM Blockchain all about? It's about model authenticity and data immutability over time. So we have the possibility to, again, use another very advanced technology based on the Bitcoin blockchain registration technology to upload files in order to register them on the blockchain, and of course embed these documents with a fingerprint, a digital fingerprint that guarantees their authenticity. Here's a view of the registration receipt of, let's say, a successful Bitcoin blockchain certification, where we have the name of the certifier, the person who loaded the file, the registration system, and the file fingerprint hash code at the bottom. And this is how we receive the additional registration information with all of the timestamps, time when the registration was confirmed, the Bitcoin blockchain block number, and so on. This is the final transaction certificate which we receive upon completion of the entire process. And therefore a very important aspect when dealing with the, let's say, recognition, if you may, of the author of given documents which are being uploaded to the cloud integrated system. Next up is the Internet of Things, another, I think, interesting aspect with regard to linking up sensor data to the BIM model, which is uploaded to the cloud. It allows us to create a complete dashboard of information regarding each and every building asset that is capable of measuring certain physical data in terms of, for instance, produced energy, temperature statuses, whether the lights are on or off, if there are any presence of people within the building, and so on. You can see here we also have a complete dashboard of information here on the right hand side, where we have the temperature measurements coming from each and every room in the building. Very easy to read information also. What are the possible applications? Definitely we have HVAC. It's very common to see that we have in any building temperature measurements which are available online through online applications apps on our phones and so on. And all of these protocols of communication can be fed into BIM IoT, also for facility management purposes, for lighting control, for fire detection also, why not? And even for facility management aspects using QR codes. Let's have a look at a video here. We have a shopping center. So we were saying previously that we can grab all of the sensor data coming from our various sensors across the building. In this example here, we have a shopping center with 52 different environments, and for which we have located various temperature control, lighting control, switch control, even the presence of people can be added to the entire system in this very neat dashboard, organized according to various categories of data, humidity levels, and so on. Here we have our renewables energy system, for which we have data coming from the photovoltaic systems with the relating power outputs for each of the strings of modules. So we can see each system, how much energy is being produced. Same applies also for our wind turbines. If we have these installed, energy measurements can also be conveyed to the BIM IoT dashboard. Electrical systems, cabinets regarding our various circuits which are supplying power to the various areas of our shopping center. These can also be addressed in terms of power dissipation, overheating, and so on. Outdoor lighting, street lighting can also be, for instance, monitored. Together with indoor lighting, here we can see a view using the an internal camera for video surveillance purposes. We can also access our webcams using the most common protocols of video streaming, and these can also be viewed within the dashboard. In fact, here we can select the camera just to see what's going on in that specific room. And this is all information which is being linked to specific objects within the IFC model. Complete interoperability and access to data in real time in this case. Here we can also see the statuses of our locks on windows and doors to see if they're open or closed and so on. Temperature, occupancy data, humidity levels, these can also be sent to the BIM IoT and viewed within the graphical interface here, for which we can also look for any strange values which are coming from any rooms, for instance, overheating, or the HVAC system which isn't working will of course also be detected because of a low temperature in that room. We can set up different, let's say, criteria for looking for data within the building. Here we have again a case study involved with the railway station. This was also presented as part of the Technology Leadership Award. And where we have even more details which are added on our territorial scale map, coming from a dynamic survey with laser scanning technology. Of course, the IFC world means interoperability, and the goal today for us at ACCA is to move toward this kind of open workflow. Here you can see the panorama photos that were taken together with the laser scanning campaign, for which we also produced detailed models, which were then federated on the GIS map, and for which we have also obtained all of the information regarding the components, their technical specifications, information regarding their maintenance, and so on. Same applies also to these objects here, which were also laser scanned and present as individual geometries within the entire structure of the IFC model, again with all of their information, which can of course be enriched in time. Further details here with both a BIM model and a point cloud scanned campaign, and a complete view of the entire system, the entire combined federated model with the real-time rendering. Here's another part of the track, including the tunnel, which was also scanned from inside using specific railway scanning technology and brought into the APIM cloud ecosystem. So you can imagine how powerful this entire system is in terms of facility management also. Okay, all of the details there. Again, once we're in the cloud with these models, we can also access the APIM reality to experience viewing and accessing documentation from a VR headset. Next up is our IFC server. Next generation IFCs, that's what we're actually talking about. The next generation of IFCs will have to be focused on file-based data exchange and the new ways of working with a connected common data environment and the application of connecting digital twins between each other. So we've revolutionized the concept of IFC files by transforming their use in the BIM process from static to dynamic. What do I mean by static to dynamic? We have the possibility here to share an IFC model through the IFC server data and connecting it through API connection to various types of clients. This basically means that the IFC model can be continuously fed with data coming from different other applications. For instance, other BIM authoring tools, or from the information coming from in the Internet of Things, or other information coming from mobile devices and so on. We're talking about a real-time management of a single source of information around an IFC file, making it available to any client through these special APIs for accessing, reading, modifying, even inserting and deleting an entity or a property within the IFC model, which has been uploaded to the server. We'll have a look at a video to show you how this works. In fact, we're going to be listening to Michelangelo.
I hope everything is clear so far. And now let's see a video where we show our solution as IFC server and the integration with some clients. editing IFC files with BIM authoring software that become as IFC server clients. Example with Autodesk Revit. This is a Revit model exported in IFC and uploaded in as IFC server. This is the IFC model uploaded in as IFC server and viewed in the browser. Thanks to a small Revit plugin, all the updates of the model are notified to as IFC server. Here is the IFC model updated in the browser. Let's add more information on the updated objects. Let's update in Revit the geometry of some walls. Here the updates in the IFC model without exporting any file. Updates are applied in real time and reflected on the users that are viewing the model in the browser. Visualization of IFC files in virtual reality thanks to the data serialized by as IFC server. Example with ACCA as BIM reality. This is the IFC model just updated with Revit and now navigated in a virtual reality environment. We can see both the updates made in Revit and the other information added on the common data environment. Let's now update the IFC model directly from the virtual reality environment. All happens in real time. We can download the IFC model updated with Revit and the virtual reality. Let's verify the correctness of the updated IFC file opening it with other visualization software such as Solibri. Now we check it with the software as BIM Viewer Plus. Simultaneous display and modification of several federated IFC files thanks to the partial serialization of data possible with the as IFC server. Example with ACCA as BIM Editor. These are 22 federated IFC models with 110,000 elements and 3.2 GB of data serialized from the server and navigated in the browser without any performance impact. We can see that the federation is composed of punctual works and linear infrastructures, buildings, railways, roads and bridges. Always from the browser we can navigate the federation of the IFC models in both first person and perspective view. Now let's select only some parts of different IFC models of the federation. Only the selected parts are serialized and streamed to an editor for further elaborations. Here in BIM Editor only some parts of the entire 22 IFC files federation are downloaded. Let's replace an old electric traction pole with a new one. Let's move the telecommunications antenna on top of one building. Let's remove some bridge guardrails. Let's add 3 new properties to the chimney of the building. All the IFC files of the federation are updated in real time. Use of clients such as mobile devices and IoT to update IFC files stored on as IFC server in real time. Example of facility management with ACCA as BIM facility. This is ACCA Software's headquarters. This is the IFC model for the facility management. Let's see an asset tracking example. The maintenance worker moves an object in the inside of the building. Registers its operation with the smartphone. The IFC model is updated in real time. And that's all. Thank you everyone for your attention.
Okay, so I hope you enjoyed the presentation there by Michelangelo of the AS IFC server application. In fact, this kind of integration was practically impossible up until today for an IFC file. Next up is another case study with the Italian electrical transmission system operator called Terna. Here we have another video, a proof of concept study. This transmission system is based in Rome, and manages the Italian transmission grid, as I was saying, called Terna. They're also in charge of many other business opportunities and non-traditional activities with regard to energy transmission. They also operate in Brazil, Peru, and Chile, managing over 74,000 kilometers of electrical power lines and stations. Terna is in fact the 6th largest electricity transmission grid operator in the world for size of its electrical grid. Here you can see in this case study, we started to model the electrical transmission station, starting off from typical 2D CAD information to build up the BIM model within our BIM authoring software for architecture, Edfish. We also modeled all of the supporting structures, steel supporting structures, placing them correctly into position together with isolators, cable connections, and so on. Specific objects were used from the MEP modeling environment to set up the cables and, let's say, represent the effect of the catenaries leading from one supporting structure to another, and also precise models of transformers and other electrical components and devices. All of the documentation generated automatically with cross-sections, plan views, isometric views, and so on, leading from a complete and detailed modeling process of the entire structure. Here we have a real-time rendering view to complete the entire project documentation production. And again, the integration with our cloud integrated system, where we were able to add additional information coming from both the BIM authoring, technical specifications, photographs, other survey information, PDFs, information regarding the structures, and completing it with all of the hashtag BIM information for precise meta data search filters. These are the renders that were generated directly from the model, together with the VR experience, which enabled us to take a virtual tour of the transmission system and also access directly all of the information regarding each of the components directly from the cloud. So you can see this seamless interaction between the completed model produced with our BIM authoring Edfish and the cloud integrated system. Okay, so from me today, that's all I have to show you. I think we've covered a wide range of different solutions in our OpenBIM workflow, covering all aspects of collaboration, coordination, BIM authoring tools, the cloud integrated plugins, and so on, to make the BIM implementation experience and access to the latest technologies as seamless and as easy as possible for anyone involved in the industry. I hope I was able to provide you with some interesting insights and how we have focused on these technological advancements, of course. And thank you again from all of us here at ACCA Software